Greetings and salutations. On Monday, we were looking at the power rule and we came across a problem, which was that we need an antiderivative for 1 over x. We were able to answer this question using the fundamental theorem of calculus, which tells us that the integral defined function of 1 over t is an antiderivative for 1 over x. We then began to study this integral defined function, and we found out it's a logarithm. But this logarithm's base we found was e, 2.718, and so on. We call this the natural logarithm. The fundamental theorem of calculus is what tells us that the derivative of natural log is 1 over x. We also get this integration formula where the indefinite integral of 1 over x dx is the natural log of absolute value of x. The absolute value comes because there's a difference between the domain of 1 over x and the domain of natural log of x. And of course, because it's an indefinite integral, we can't forget the plus c. If we look again at the graph of natural log of x, we can quickly see an important fact, which is that natural log is always increasing. And that means that it is going to pass the horizontal line test. It's a one-to-one function. And that it is invertible. And today, I want to discuss the inverse of the natural log function, which is the exponential function e to the x. Really, it is more appropriate to say that natural log of x and e to the x are inverses of each other. And let's remember what this means. If we take the natural log of e to the x, we just get back x. And also, if we take e to the power of natural log of x, we again just get back x. Let's look at some examples of how we can use these inverse properties to solve equations. Let's solve e to the x squared is equal to 4. If we take the natural log of both sides, then the left-hand side is the natural log of e to the power of x squared, which is just x squared. The right-hand side is just natural log of 4, and so we get that x is equal to the square root of the natural log of 4. We do need plus or minus because we didn't specify a restricted domain ahead of time. Let's now solve natural log of 5x minus 1 is equal to negative 1. This time, we can say that e to the power of the left-hand side is equal to e to the power of the right-hand side. The left-hand side is e to the natural log of 5x minus 1. And again, using these inverse properties, this just simplifies to 5x minus 1. The right-hand side was e to the minus 1, which is just 1 over e. At this point, we just add 1 to both sides and divide both sides by 5 to get that x is equal to 1 over 5e plus a fifth. We can now determine the derivative of e to the x. If we start with the equation y is equal to e to the x, well, this is the same thing as saying that x is equal to the natural log of y. We can then take the derivative of both sides with respect to x. And on the left-hand side, we just get 1, where on the right-hand side, we get 1 over y times dy dx. If we rearrange, we get dy dx is equal to y. Since we said that y is equal to e to the x, this means that the derivative of e to the x is equal to e to the x. This makes e to the x a very unique and a very special function because it is the only function which is equal to its own derivative. Including the chain rule, the differentiation formula is that the derivative of e to the u is equal to e to the u times du dx. Notice that the exponent doesn't change. Now, if e to the x is equal to its own derivative, then that means that it is also equal to its own antiderivative. And so the corresponding integration formula is that the integral of e to the x dx is equal to e to the x plus c. Or if we want to include a u substitution, that the integral of e to the u du is equal to e to the u plus c. At this point, you can now use these formulas to work on the assignment that's been posted to Canvas.